This video we'll be talking about a problem on conservation of momentum and coefficient of restitution. We have been given here a frictionless tube through which a ball is moving and it's falling by a height of 2 meters. As soon as it comes out, it's hitting another ball which is hanging from the ceiling, the length of thread being 1.2 meters. We have to find the height to which this hanging ball will rise after the impact. So we have to do that under two conditions. First is when the collision is perfectly elastic, which means the value of coefficient of restitution is equal to 1. And in the second case, when the coefficient of restitution is equal to 0.7. For this, first we will have to find out what is the velocity u1 here. u2 of course will be 0. To find this u1, we will have to equate the potential energy and kinetic energy of the ball, because at this point all the potential energy for 2 meters height is converted completely into kinetic energy. So the potential energy here is mgh and the kinetic energy is half m u1 square. The masses on both sides will be cancelled and we get the formula for u1 as 2gh under square root. Calculating that gives us 6 meters per second. Next we have to apply the conservation of momentum equation. So that tells us that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 is 10 newtons by g, u1 we calculated as 6.26, m2 is 20 by g, u2 being equal to 0, and on the other side again we get m1 10 by g, v1 is not known, plus m2 that is 20 by g into v2. Here 10 by g can be taken common and it will cancel from all the values, and we are simply left with v1 plus 2 times v2 equals 6.26. Next let's use the formula for coefficient of restitution, which says the coefficient of restitution is negative of final relative velocity divided by initial relative velocity. Now here if we remember correctly, there are two bits. The first bit the value is equal to 1 and second bit the value is equal to 0.7. Let's start solving it. So 1 equals minus v2 and v1 are not known divided by u2 which is 0 minus u1 that is 6.26. This gives us the relation v2 minus v1 as 6.26. Now we have two equations which have both the variables v2 and v1 in it, and solving these two equations will give us the values of v1 and v2. Adding the two equations make v1 cancelled and we get 3 times v2 equals 2 into 6.26. So v2 value equals, that gives us 4.17 meters per second. Substituting this back in equation 2 gives us the value of v1 as v2 minus 6.26, which is minus 2.09 meters per second. Now the problem just doesn't end there. We are actually supposed to find the height to which this ball will rise after it moves with this velocity. So we are supposed to find this height h. Let's just call it as h2. Now for that we know that this body is moving right side with a velocity 4.17 meters per second initially, and it is reaching a height here wherein it loses all its kinetic energy. So once again here we will have to take the equation between potential energy and kinetic energy. Potential energy, as we know it, it is m into g into h2, and the kinetic energy is half of mv square. So in this case, v2 square. The value of m will again cancel on both sides, and h2 will be equal to v2 square by 2g, which after calculation gives us 0.886 in meters. Now for the b bit, we have to take the coefficient of restitution as 0.7 and find the different values of v1 and v2. Then use that value of v2 to find the height. For the b bit, equation number 1 remains the same. The coefficient of restitution, we have to take it as 0.7 and follow from there. So once again, let's take the formula for coefficient of restitution, which is negative of final relative velocity divided by initial relative velocity. The value of u1 remains same as we calculated. u2 will again be 0, and we have to find the values of v2 and v1. Let us substitute all the known values. So E is 0.7 minus v2 minus v1 divided by u2, which is 0 minus 6.26. So that gives us the value of v2 minus v1 as 4.382. Now that we have both equation number 1 and equation number 2, we just need to solve them to get the values of v2 and v1. So let's again add equation number 1 plus 2, which will cancel the value of v1, and we get 2 times v2 plus v2 equals 10.642, or 3 times v2 equals the same value. So we get v2 equals 3.55. Substituting this value back in equation 2 will give us 3.55 minus v1 equals 4.382, or v1 equals 3.55 minus 4.382, which is negative 0.832. Finally, again we have to take and equate the potential energy with the kinetic energy. So let's put it, mgh equals half mv square. So the velocity here being v2. Mass again cancels on both sides, leaving us the formula h equals v2 square by 2g, which gives us height of 0.64 in meters. So that is our answer. So this is the answer for a bit, and this here is the answer for b bit. Hope you have understood this question perfectly. In the next video, we'll take up another of the questions. Thank you.